Hello everybody, happy Wednesday, halfway through the week. We have been for about a week been solving one variable inequalities, which means we're graphing on a number line. Today we're going to jump into linear inequalities, which means we're going to have two variables. Therefore, we're going to be graphing on a coordinate system. Very, very similar to what we were doing before. The directions are going to be very similar. Again, we're looking for infinitely many solutions in the fact that an equation has specific 1, 2, 3, limited number of solutions, where an inequality has infinitely many. So that again be the case on a coordinate system versus a number line. If we remember, just a little review here, when we were doing our one variable inequalities, one variable, one dimension, therefore a number line. That's what you got to remember. One variable, one dimension, one number line. Moving into today, the directions that Mr. Klug put on our homework worksheet for Monday, I think it was. These directions right here are going to be very, very similar to what we're going to do today, in the fact that we are still going to be writing our corresponding equation. You might hear me say an associated equation. Same thing. A corresponding equation, associated equation, same thing. We're still looking for boundaries, but in this case, we're not looking for boundary points. We're looking for a boundary line. So therefore linear, get it? Linear inequalities, boundary line. We're still going to plot. We're going to plot those boundaries. We're still going to test the regions in the original inequality. We're still doing that, the same rules. And we're still going to be shading. Difference is we're not going to write a corresponding inequality. We're not going to be writing a corresponding inequality. Because we can, on a number line, you can identify them a little bit more, but in a coordinate system, it's literally the only way we can write all of them down is on a picture. We draw a picture of the solution instead of write the solution. So if we come down to a problem, we're going to try. Get down to the nuts and bolts. The inequality we're going to try to graph is y is less than or equal to 2x minus 1. First thing we have to remember is we have to write its associated equation. So y equals 2x minus 1. There's the associated equation, just like before. Now we're going to solve it. Now you'll notice we have two variables, which mean x and y, which means we're now on a coordinate system. So one thing we want to remember when we're graphing these, hopefully we remember the y equals mx plus b. M is the slope. B is the y-intercept. Hopefully we remember that. When it comes to graphing our equation, I'll do it in blue. When we graph our equation, we have to remember that purple is that 2 is the slope, and if I change subtraction to addition, I get -1 is my y-intercept. So rather than write that, I suppose I could name it M and B. That double arrow looks goofy. So we have M and B. So if you remember graphing lines, we've done that plenty of times throughout the year. Graphing lines, because it has a y-intercept of -1, that tells us it's going to cross the y-axis at -1. And the slope, again, b equals 1, slope equals 2. Many of us would like to write slope as a fraction, because remember it's rise over run, change in y over change in x. So if you follow my pointer, we're going to go up 2 over 1. And again, following the pointer, up 2, I should say to the right 1, and there's another point. If you continue to do that, you could even, if you wanted to, go down 2 and over 1, because a negative over negative is still positive. So if oops, that's not in the right spot. Down 2 over 1, should be right there. Now, if I try to graph a line, we'll see how this goes. Through those points, I don't know if I can change it. Hang on, see if I can do that. There's my line. It's as close as it's going to get. And remember, it's a line. It goes forever. That line is dividing that coordinate plane in two pieces. There's like above it to the left, and there's below it to the right. Now, remember how we tested we looked for our boundaries? This is our boundary in this case. Just like before, we had to decide, do we want to include that boundary or do we not want to include it? So that comes down to, do we want to include the values of x and y that make that equal? Do we want it equal? And because of less than or greater than, Yes, it's less than or greater than, less than or equal to. We want the equal. So therefore, we're going to graph, like I did, a solid purple line. It's going to be solid. That means that all of those ordered pairs on that line are in fact making our inequality, our original inequality, true. We want them part of our solution. Then we move on to testing the region. We have to test, some values. Now we have to test an ordered pair, an x and a y. Again, just like both Mr. Klug and I say, why not test 0, 0? 0, 0 is a nice, easy point. Why not test it? Now, truthfully, you can test any point you want as long as it's not on the line. You can test any point you want as long as it's not on the line. If it's on the line, we already know, do we want a part of the solution or don't we? So if I test 0, 0, again, in the original inequality, put 0 in for y, put 0 in for x, I get 0 less than or equal to negative 1. Is 0 less than negative 1? No, it is not. This is a false statement. So therefore, when I come over here and I pick my point 0, 0, I do not want it part of my solution. So therefore, I am going to shade, what color do I have there? Yep. I'm going to shade all of the region on the other side. 0, 0 did not work. So therefore, I'm going to shade all of this region. Now, truthfully, it's more than just the coordinate system itself. Remember, this could go forever all the way over here if we wanted it to, right? We could graph that whole or shade the whole entire region. Obviously, you don't have to shade the whole thing. But remember, that line is the boundary between what works and what doesn't work. Well, that kind of looks like a mess, so let's get rid of that. Some of you may choose, rather than shading that heavily, some of you may choose to get your pencil to work. Some of you may choose to just shade it this way, rather than shading the whole thing. That shows, again, that all the ordered pairs on the bottom right work, and all the problems on the top left don't, because 0, 0 did not make it true. We tested the point 0, 0, didn't work. Okay, that's it. That's all we have to do. We don't have to write an inequality. We don't have to do anything else. It's just the picture. That is the solution to the inequality. Hopefully that makes sense. And if you need to, you can come back and watch this video again and stop it in between. Now that we went through a problem, here are the directions. And again, pointing out those similarities, we're going to write the corresponding equation. We're going to graph that boundary. In this case, it's a line. We're graphing the boundary. I should have said boundary. You know what? I should have put that in there. What am I thinking? We should have this say boundary line. Oops, boundary line. This should say boundary line. Glad I caught that. And then we're going to graph that boundary on a coordinate system. Now, what you want to remember is solid line is if it makes it work. Dashed line if it doesn't. That might be too dark. A solid line if it makes the inequality true, and a dashed line if it doesn't make it true. Solid versus dashed. Some other similarities. We have to test the regions. We did that, and then we're going to shade the regions. So hopefully you see the similarities. Oops, that's not what I wanted to do. Give me 1 second. Oops. There we go. Make that so we can read it. There we go. So again, the directions are very, very similar. So if you want to copy these down somewhere, that'd be a great idea as well. Graph that boundary line, determine if it should be dashed or solid, test the regions, and then shade the regions. There are the directions we want to follow. Again, come back and watch this video again if you want to copy all that down. Here's another example. This one's a little bit different. You'll notice it's a little different because we have just a greater than sign. It's not greater than or equal to, it's just greater than. So directions are still going to be as they were. Equation. And then we're going to graph that. Again, our slope is -3/2. Our y-intercept is 4. Again, because it has two variables. Remember, these are different. They have two variables, so we're graphing a line. Now, that being said, my y-intercept is 4. My slope is -3/2. So again, I'm going to go down 3 and to the right 2. Down 3 to the right 2. And if I do that again, down 3 to the right 2. Now, before I draw that, that's not where it goes. Before I draw that one, before I draw that line, I still didn't do it in the right spot. Down 3 to the right 2. There we go. Woo! Before I draw my line through there, I want to remember that this inequality, shouldn't do it in that color, this inequality makes me not want a solid line, I want a dashed line. So when I draw my dashed line, this is going to be a little bit bigger. Oops, that's not where I want to go. There's my dashed line. It's not a solid line. I probably got a little big. There we go. Again, it still divides the region into two, divides the coordinate system into two regions, bottom left, now this time top right. But notice our boundary goes this way because it's a negative slope. The boundary line is going the other direction. If you need help remembering how to graph lines, make sure you contact us and set up a time and we'll figure that out for you. Once we get our boundary graphed, then we have to test. Again, I can test the point 0, 0 because it's not on the line. So if I test that point, put it into the original inequality. Again, we only pick 0, 0 because it's a nice easy number to work with. So I get 0 is greater than 0 plus 4. Is 0 greater than 4? Again, 0 is not greater than 4. It doesn't work. This is a false statement. If it does work, if 0, 0 worked, you'd shade this region, but it doesn't. So I'm not going to include 0, 0. I'm going to go back to the other side. And I'm going to shade what's over here. And again, that is my solution. So, long story short, we cannot write an answer for we cannot write an equation or a statement or anything like that for our answer. It's just that picture. That's all the further we can go. To graph the boundary, it's a line, not a point. And to graph that line, we need a slope and a y-intercept. Hopefully that makes sense. We're probably going to practice this today and tomorrow, and then we'll probably take a quiz on Friday again. Hopefully it all works. But again, remember you can reach Mr. Klug or I by way of email and or the Google Meet app. We can set up a time to work with you. Please let us know if you're struggling. We're here to help you. Have a good one.